low pass filters. Pass filters. Right? So now this thing I had told you that there is something called neighborhood. When we operate on single pixel, then it is called point processing. And whenever there is a neighborhood of a pixel, and we do the calculations based on the intensity of the neighborhood pixels, that is called neighborhood operation. So there are two types of operations. Already you are, you know what is the neighborhood. So this is again that type of knowledge. What is the neighborhood? You know that. Okay. So simple neighborhood operations involve finding out the minima of the intensity values. Let us say there is a 3 by 3 pixel neighborhood. Okay. There is a 3 by 3 neighborhood. This is an image. And consider that we are having a neighborhood here. So 3 by 3 neighborhood. So max min, when we say minimum operation. So what is minimum operation? Minimum operation means that we are trying to find out the minimum value of the 9 values. This is a 3 by 3 neighborhood. 3 by 3 neighborhood. So min means minimum of 9 values. When you say max, we are trying to find the maximum of 9 values. Okay. When we say median, it is a median filter. That means what? We will find out the median value of the 9 values. Median of 9 values. What is median? You can understand from this example, which is written here. Suppose there are some numbers. These are the numbers. Let us say these are the numbers. 15, 7, 1, 18, 15, and 24. Suppose these are the numbers. Okay. Then you want to find out the median of these numbers. Then you either arrange them in ascending order or descending order. So if I arrange them in ascending order, so that will become 1, after that 7, after that 15, 18 and 24. Increase हो रहा है इस तरह से, ठीक है ना? 1 is the least, 24 is the most highest. Then the middle value, third value, third entry is called the median. Is it clear? If there are 7 values, then the fourth one will be the median, like that. If it is even, then there will be 2 medians. Had it been 1, 7, 15, 17, let's say 18 and 24, then there are 2 medians. So I think this median you have studied in the minimum filter or maximum filter or a median filter. What they will do, and that value will be assigned to the center pixel. For example, in this neighborhood which I made at the top, that value will be assigned to this fellow, the middle fellow. And then afterwards, after that, my neighborhood will shift like this. And again, I will do the same operation and I will change the value of this fellow. Then this fellow, like that, it will keep shifting. So that way, all the pixels of the image will undergo a change, except the boundary pixels. Of course, your neighborhood, see, if you suppose you keep your 3 by 3 here, 3 by 3 neighborhood. In that case, this will be, of course, changed. But what about this or this or this at the right at the top? You cannot place your grid here, 3 by 3 grid, so that either you have to place it this way. Then you can change this middle pixel. So there are ways to deal with boundary pixels, but leaving aside these boundary pixels, you can imagine that the other middle part of the image that can be assigned the new intensity value in this manner, which I told you, minimum, maximum, or median. So these are called filters accordingly. Okay. So here you can see that this is a simple neighborhood. Suppose these are the intensities of these pixels. Suppose we are doing something to it. It's not finding out the minimum or maximum or median of this. Rather, we are doing something R, this S, T, U, V, W, X, Y, Z from our side. This is called filter mask. This is called filter mask. Okay. These are the original intensities of the. Now, what I will do, I will put this mask starting from here. Subalize mask ko I will place here. That is the filter, spatial domain filtering method I am telling you. Okay. That this is the mask I have put here. So there are values A, B, C, D, E, F. These are the G, H, I. These are the intensity values. And then there are something called the filter mask values. So filter mask values, if I write here, so let us say the mask values are R, S, T, U, V, W, and X. So after you have put the mask here, you multiply A by R, B by S, corresponding pixels of the image and the mask. So this is what you are required to do. The calculation is written here. You can see that. You understand? V into E. This middle one gets multiplied by the middle one. This one gets multiplied by this. This one gets multiplied by this. This one gets multiplied by this. Like that. Okay? Just see this. And whatever value comes, whatever value E processed comes, that is assigned to this middle pixel here. Now the new value is E processed. Previously it was E. Are you getting? So this way we will change all the values. Then we will shift the mask here. We will change this fellow. We will put the mask here after that, and so on. All these values will be changed. All this row value will be changed. After that, we will shift the mask here this way. Again, we will do the same thing and we will change this particular row. And till the last, your mask will be finally here. And you will be changing this pixel. I think it is clear. So that will be called the filtered image. This is called image filtering. Okay, in the spatial domain. So if you want to write mathematical equation corresponding to this, you can write. This is the filter mask entry, mask value. Values, I should say, because there is summation, so all the 9 values will come. So one value correspondingly image intensity, image pixel intensity, image pixel, that is denoted by this.
Sir,
Yes.
hello. Sir, you are choosing a mask, na?
Yes.
So how to choose those values of the kernel?
Yeah, you will just see. You will just see. Just wait. And your fundamentals will be clear. Just wait. Okay. So I think the procedure is clear. Or is there any doubt in the procedure?
Okay, very much clear, sir.
Very much clear. Proceed ahead. Now, actually, you have to slightly understand. चलो इसको ये important बात नहीं है. So what we are doing is that values. Okay. So you start with the low pass filter. This is low pass filter. Till now it was general, now it is low pass filtering. So just think as if the mask values are 1 by 9, 1 by 9, 1 by 9, like this. ठीक है ना? और ये मास्क हो गया, मास्क हो गया, और इमेज तो है ही आपके पास में. Do this type operation. Suppose I do this operation which you have learned now. तो क्या होगा? देखो 1 by 9 into whatever is the value of the intensity wherever you put it. Suppose that is this pixel intensity is A, below this. Okay. So A plus 1 by 9 into 1 by 9 into A, B, C, D, E, G, H, I. The last one was I. So this is I. So 1 by 9 into I. So that means 1 by 9 A plus B plus C plus and so on up to I. So there basically what you have done, you have added all the intensities of the image of the 3 by 3 neighborhood, okay, and divided it by 9. So these are 9 values which you have added, divide by 9. So that means what you have done, you have done the averaging of the intensity values, isn't it? This process is the averaging you are doing. So therefore this particular mask, if you use, this is called averaging, simple averaging mask, right? This is called simple averaging mask because of this, because it does the averaging of 9 values of the image intensity. I think it is clear.
Yes,
okay.
sir.
If it is clear, this mask can be written as this way also. This is the way of, another way of writing it. भाई मैट्रिक्स है ना, देखो तो मैट्रिक्स में क्या होता है, you can take this 1 by 9 outside, no problem, and this is rest of the matrix. ये आपकी मैट्रिक्स है, ठीक है ना? तो आपको पता ही है कि this is as good as the previous 1 by 9, 1 by 9, 1 by 9. ये मास्क देख लो, this is a mask 1 by 16 multiplied by this. So you understand what is the meaning. इसका मतलब ये हो गया, इसका मीनिंग ये हो गया. You understand that? ठीक है ना? तो इसमें ये भी एवरेजिंग मास्क है, but here the averaging is not equal at every place. You can you see that this center pixel, this is being given more importance. You are attaching a higher weight to this center, this thing. Put naturally the image intensity at this place, at the center place, will get more boost. Okay, so that comes by experience which mask to use and which one not to use. But this is a mask which does again the sort of averaging. If you see, so that means it will be 1/16 into A plus 2/6. यार ये ऐसे चलेगा ना तो गड़बड़ होता है. इसका मतलब मीनिंग ये हो गया ना तुम्हारा 1/16 into A plus 2/16 into B. अगर ये मान लो A है, ये B है, ये C है, तो like that. So ये भी तो देखो 1/16 कर दिया तुमने, but in some manner it is also an averaging. It is also an averaging. ऐसे चलेगा ना ये. तो ये भी एक एवरेजिंग है एक तरह से, बट वेटेड है, वेट्स आर देयर. तो ये मतलब स्टैंडर्ड है ये चीजें. यू कैन सी हियर, ये एक्चुअल इमेज है. ओरिजिनल इमेज इज एट द टॉप. ठीक है ना, ये ओरिजिनल इमेज, ओरिजिनल. तो इस पे मास्क लगाए देखो हमने. दिस इज 500 पिक्सल लगाए हमने. So this is 3/3 mask applied on this. So when 3/3 is applied to the whole image, then this is the result. So this is 3/3 mask. This is 5/5 mask. Similarly, this is 9/9 mask. This is 15/15, and this is 35/35. हैवी मास्क मतलब हैवी आपने लो पास फिल्टरिंग की है इसमें. 35/35 means you can imagine that this is a big mask and that has been put here first. In to start with, it has been put here and then shifted as I told you. So they look the amount of blurring. Can you see that amount of blurring in each case? ये बात है. So that means larger the mask, more blurring. ठीक है ना. या हैवी लो पास फिल्टरिंग मतलब इसी को कहेंगे हम. इट्स ए हैवी लो पास फिल्टरिंग. तो इफेक्ट देख लिया डिफरेंट मास्क का. सो ब्लरिंग का मतलब डिटेल्स विल नॉट बी विजिबल टू यू क्लियरली. डिटेल्स in the image will not be visible now. All are sort of merged with each other. All the edges are merged with each other as in the last one. See the application of this. This is the original image of the sky, and then the 3/3 mask has been applied. So after application of the mask, this is the image. This is low pass filtering, average low pass filtering by averaging mask. And then we have done the thresholding from here to here. This is the process of thresholding. Are you getting? Thresholding means that I have selected some threshold level. Below that, I have made the pixels black, and above that threshold value, white. So that is thresholding. So what is the advantage? You will see the advantage that small bodies in the sky, small stars, etc., they are gone finally. And only the prominent ones, they get highlighted. So if you have to work on this part of the image, you can work further. Just to find out what is length, width, so many things you may like to find out. As I told you one day. So this was ये जो अभी average filter which you have done just now. This is called linear filtering. आपका जो फाइनल ई प्रोसेस था, ई प्रोसेस वाज इक्वल टू ए इंटू whatever equation you wrote, 1/9 plus b into 1/9, so on. This was a linear equation भाई, है कि नहीं linear? बताओ, इसमें कोई नॉन लिनियरिटी लग रही है क्या आपको? This is the equation of a line, है ना? y is equal to mx plus c type things. Now let us come to non-linear filtering. तो जो भी अभी I told you that median filtering, है ना, in which the mask is put and median of the values, 9 values will be taken, and whatever is the median, that will be assigned to the center pixel. That is called median filtering. Okay. So in this case, we do not construct a filter. We don't need to construct a mask, filter mask. That means in case of linear filtering, of course, you have to construct, but in case of median filtering, you just put the grid without any value, 3x3 grid over the image, and just pick out those 9 values and do the calculation of the median. And whatever median comes, assign that to the center pixel. That's all. Salt noise is also called salt and pepper noise. Salt and pepper noise, I told you that this noise looks as if the salt particles, and salt and pepper noise या impulse noise बोलते हैं. So that looks like this. You can see on the left, ये PCB का मतलब ये rather वो मतलब circuit का वो है, layout है, ठीक है ना? ये कनेक्टर वगैरह आपको दिखाई दे रहे हैं ये सब. तो यहाँ पर you can see the black particles on white background. ये पोर्शन जो है, यहाँ पे आपको black particles दिखाई देंगे और black connectors हैं. These are the black connectors on which you can see the white particles. Okay, so this is salt and pepper noise. So if you apply your linear average filter to this image, then this is the output image, middle one. However, if you apply the median filter to this original image, then this is the output. And you can yourself see that median filter is very effective in removing the salt and pepper noise. Of course, noise cannot be removed completely, as I said in live. So there is some noise still left, and that will remain there. You can't do anything about it. But largely 90% noise is removed. So median filter is the best for removing salt and pepper noise. Example, here noise has been added, salt and pepper noise has been added to this image in MATLAB only. Natural नहीं है ये actually add कर दिया हमने, just to see the, just to simulate the environment of salt and pepper noise. We have added this noise using MATLAB, and then we have applied the average filter. And just एक मिनट मैं दे रहा हूँ. नहीं ले कहाँ गया हमारा? Thank you. ठीक है ना? तो ये जो बॉर्डर पिक्सेल्स हैं, तो देयर आर सम मेथड्स. These are the 5 methods. 1, 2, 3, 4, 5. What are the methods? ठीक है ना? First thing is omit the missing pixel. ठीक है ना? क्लियर ही मत करो, मतलब कुछ मत करो, ठीक है ना? One is don't do anything. Second is to pad the image. You pad the image. Pad का मतलब होता है कि I am adding one extra row at the top. यहां पर मैं देखो ये पिक्सेल्स की एक रो जो है मैंने ऐड कर दी, और इसी तरह से एक कॉलम यहां पर ऐड कर दिया, एक कॉलम मैंने यहां ऐड कर दिया, और एक कॉलम बॉटम पे ऐड कर दिया। ठीक है ना? कुछ समझ रहे हो बात को? ये मैंने ये वाला कॉलम ऐड किया है, ये दिस कॉलम आई हैव एडेड, दिस रो आई हैव एडेड, सिमिलरली दिस कॉलम आई हैव एडेड, ये वाला ऐसे करके ऐड कर दिया। और इस कॉलम की इंटेंसिटी की वैल्यूज जो हैं, या तो मैं सबको 255 ले सकता हूं, इसको भी, इसको भी, इसको भी, इसको भी, इसको भी, ऑल आर 255 and then 255. That means border, I am assuming the border to be slightly white होगा, or else I can do 0. ये पिक्सल की वैल्यूज जो है ये सारी जीरोस ले सकता हूं। दैट मीन्स मैंने बॉर्डर का पिक्सल जो 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 इमेज का बॉर्डर है उसको ब्लैक एज्यूम कर लिया। बात समझ में आ रही है कि आई हैव एडेड one row column at the left, one column at the right, and that added pixels I am either assuming to be at intensity value 255 or 0, which was uncovered previously. Now it is covered, and there is no problem now. Bas theek hai. This is the one way of doing the things. That means padding of the image, या तो all white से या all black से padding कर देते हैं, and we do the values of intensity here. I have added one row, one column, and again at one row at the bottom, one column at the left. I have added, but the intensity values of those pixels are same as border pixels. मतलब 255 या 0 नहीं किया मैंने, ठीक है ना? Rather, I have kept the intensity values of those pixels to be same as the nearby border pixel, and then I am doing the filtering operation. So say now कि I am biased towards border, same values are, I am assuming for one more border, and I am doing the calculations. So that means border characteristics will be preserved that way. Is there any doubt or in the procedure? Whatever result will come, that we do not know, but and nobody can evaluate which method is good and which method is bad. Then there is truncation of the image. There is truncation of the image. And when you say that truncate the image, that means again it is the same type of thing. Okay, border pixels have not been assigned any value. Don't worry. Later on, if suppose this was the situation, this is your image and your border pixels have not, आप इस पोर्शन में तो कैलकुलेशन सारी हो गई ना, सो देयरफॉर आप इमेज को यहां से ट्रंकेट कर दो, कैंची चला दो, सीजर्स, so that means your image size reduces. In that case image size एक पिक्सल रिड्यूस हो गया। तो अगर 512 by 512 की इमेज थी, so now ये 510 by 510 की इमेज रह जाएगी। one this thing gone here, one pixel at the bottom. The intense, this is x plus 1, you know, this pixel is having, this is x minus 1, y remaining same, all of them are in the same column, no? तो y तो change नहीं कर रहा ना मैं, x change कर रहा हूं। तो when I am changing x, so this is x plus, because middle one is x, so this will be x plus 1 and this will be x minus 1. Similarly, this will be y plus 1 and this fellow will be y minus 1. Are you getting me? Or is there any doubt? So Del f by del x is defined as the intensity of this pixel, minus the center, this fx. So this is the definition of differentiation along x-axis. Similar will be the definition along y-axis. That is understood. Del f by del y if you want to calculate. So f of y plus 1 minus f of y. Right? So this is first order derivative. Second order derivative is defined in this manner. Del square f by del x square. Second order derivative is defined as for f of x plus 1 plus f of x minus 1 minus twice of fx. Yani ki, that means what? That means जो top pixel है ये fx plus 1 है, ये वाला पिक्सल fx plus 1 है, ये वाला पिक्सल fx minus 1 है, इसकी इंटेंसिटी minus 2 times this, 2 times the center one. ठीक है ना? कोई प्रॉब्लम है क्या समझने में? That is called second derivative along x-axis. और जैसे सेकंड डेरिवेटिव along x-axis है, ऐसे सेकंड डेरिवेटिव along y-axis हो जाएगा, है ना? f of y plus 1 plus f of y minus 1 minus 2. तो ये जो हॉरिजॉन्टल पिक्सल हैं ये वाले, these three will come into reckoning. एक, yes.